In this video, we're going to talk about multiplication of matrices. We already have an example on the screen, but before we solve it, there are three things I would like to talk to you about. The first thing is to refresh you on the key concepts in matrix. So say you have a typical matrix of elements A, B, C, D. If you look at it from this side and this side, this is a row of the matrix. So we can say this is row 1, this is row 2. So anytime you're counting this way, you're counting in rows. So this is 1 row, 2 row. If you're counting this way, you're counting in columns. So this is column 1, column 2. The order of a matrix simply tells us the row times the column, or we write it as row by column. If this has 2 rows, the columns are 2, so we can write it as a 2 by 2 matrix. That was just what I wanted to say about the concept. The second thing I want to say is how to multiply a matrix. So say we have 2 matrices. If I have a matrix like this, to multiply these 2 matrices, I will use the rule for the first matrix to multiply the column for the second matrix. This is essentially how it will happen again and again and again. I'll be using the rows for the first matrix to multiply columns of the second matrix. So you essentially use the rows of your first matrix to multiply the columns of second matrix. Don't worry, I'll really show you how to do it when we get to the examples. Then for the third thing I want to say, it's important to check when multiplication is even possible. So for multiplication to be possible between 2 matrices, the number of columns for the first matrix should be equal to the number of rows for the second matrix. If this is not true, then you cannot multiply the 2 matrices. So with this in mind, let's quickly jump into this question. We are given a matrix A and a matrix B, and they were told to first of all find AB and BA. So I'll be writing solution here. To find matrix AB, I'll write matrix A, which is 1 and 2 here, and I'll write matrix B, which is 2 and 3 here. First of all, before I even start multiplication, the first step is to check whether I can multiply the 2 matrices. How do I check that? I check the columns for this first matrix. So the columns here is 1, and the columns for first matrix is equal to 1. And the rows for the second matrix is equal to 1. So since the columns and the rows are equal to 1 and equal to each other, that means I can multiply these 2 matrices. You can do this side on something like a rush of paper when you're solving a question. So we have matrix AB is equal to, remember I'll be multiplying it this way against the columns. So for my first multiplication, I'll be using the first row, which is row 1. So this will be 1 times 2. I'll say 1 times 2. The position comes under the first row. Then I'll be going for the second column here, and because I'm still multiplying my first row term, I'll still be on the first row. So this will be 1 times 3. This will be 1 times 3. Since I'm done with all the multiplications I can do on the first row, I can go to the second row. So for my second row, I'll be using 2. This will be 2 times 2. Right, 2 times 2. Note that now that I'm multiplying the second row term, my elements are now in the second row. The next one will be 2 times 3. So it's now be on the second row and column. Now, this is equal to, I'll simplify everything inside this new matrix. So this will be 1 times 2 is 2, 1 times 3 is 3, 2 times 2 is 4, 2 times 3 is 6. So that's it. This is matrix AB. Let's look at matrix BA. So if we are asked find matrix PA, we have the two matrices line up this matrix 2, and the matrix A is 1 and 2. Like I said, we do our multiplication the way we do it. So we go rows against columns, right? Then I'll come here and I'll say 2 times 1. I'll multiply this one with this one first. So this will be 2 times 1 plus, because I'm still on that same rule, I'll plus everything there. So I'll be using this one 3 times the second, this one here. So this will be 3 times 2. We're done with this row. There's no other row to go to, and there's no other column to multiply. So we are done. That means this is equal to 2 times 1 is 2 plus 3 times 2 is 6. This is equal to 2 plus 6 is 8. So if you notice, switching the matrix does not necessarily mean that we'll get the same answer. So something like BA in matrices is not always equal to AB, like normal multiplications work. Let's look at extra examples for you to understand how to multiply matrices better. For this new example, we are given matrices A, B, C, and D. And we are asked to find matrix, the multiplication of A, C, AD, DB, and AB. Let's jump in. So to find multiplication of AC, our right solution, matrix A and C. The right matrix A have 1, 2, 1, 3. Matrix C is 1, 2, 3. Like we've been doing before, the first step you do is to check whether we can even multiply these two matrices together. The number of columns on the first matrix is 1 column and 2 columns. The number of rows in the second matrix is 1 row, 2 row, 3 rows. So the number of columns from this matrix is 2, and the number of rows from the second matrix is 3. Since the rows and columns row does not equal to each other, we cannot multiply the two. So we simply say A, C is not possible. Then we'll move on to our next question. For our next question, we are told to find matrix A, D. This is question 2. This will be question 1. We are told to find matrix AD. Matrix A is given as 1, 2, 1, 3. Matrix D is 3, 2, 1, 0, 1, 2. So we check the number of columns for our first matrix. Number of columns here is column 1, column 2. So there are 2 columns here. Number of rows for our second matrix is row 1, row 2. Since the number of columns for the first matrix is equal to the number of rows for the second matrix, then we can go ahead and multiply the two matrices. If I'm multiplying these two matrices, AD becomes, watch how I use the multiplication. So I'll start with my first row. So this is my first row multiplication against the first column multiplication here. This will be 1 times 3. This input will come into this place, the first row of my new matrix. So this will be 1 times 3. Then I'll use my second number on that row and I'll plus it. So this will be 2 times 0. 2 times 0. I'm done with this column. Then I move to the next column. I'm still on the first row, so I'll still stay on the first row for my matrix AD. This will be 1 times 2. So I'll do 1 times 2. Then this will be 2 times 1 plus 2 times 1. So I'm done with this column and this column. Next up, I'll move to my third column. So this will be 1 times 1 plus 2 times 2. Now I'm done my first, second, and third columns. So as I'm adjusting the columns are also changing here. But since I'm using the first row, all of them will stay on the first row. So next up, I'll use my second row to do the multiplication. Then I'll now say 1 times, I'll start with my first column again. So this will be 1 times 3 plus 3 times 0. This will be 3 times 0. I'm done with my first column, so I'll go to the next column. This will be 1 times 2 plus 3 times 1. Then I'm done with my second column, so I can go to my third column. Then I'll go to my third column of my AD matrix. This will be 1 times 1 plus 3 times 2. I'll need space, so I'll write it here. My matrix AD be around here, and then this is 1 times 3, which is 3, plus 2 times 0 is 0. Then I move on to the second column. 1 times 2 is 2, plus 2 times 1 is 2. I move on to the third column. 1 times 1 is 1, plus 2 times 2 here is 4. Then I move on to my second row to continue my simplification. So this will be 1 times 3, which is 3, plus 3 times 0 is 0. This will be 1 times 2, which is 2, plus 3 times 1, which is 3. This will be 1 times 1, that's 1, plus 3 times 2 is 6. So that matrix AD is, forgive me for the use of space, matrix AD becomes 3 plus 0 is 3, 2 plus 2 is 4, 1 plus 4 is 5, 3 plus 0 is 0, 2 plus 3 is 5, 1 plus 6 is 7. So this is matrix AD. To be sure whether the order of your matrix is correct, you can use the individual matrix order to find out. The matrix order of A from the question is a 2 by 2 matrix. That is, the rows is 2 and the columns are 2. The matrix order of D from the question is, remember, D has 2 rows and 3 columns. So that we write it like 2 times 3. Then the resulting matrix of AD should be equal to the matrix of A, 2 times 2 times 2 times 3. You pull out the middle terms here. If you eliminate these two middle terms, you should have something like 2 by 3 matrix. So if you were to solve matrix AD and you did not get this order, that means you are wrong. This is a 2 by 3 matrix, and if you notice here, this matrix is also a 2 by 3 matrix. After that, let's look at example 3. So example 3, we are asked to find matrix DB. Matrix D is a 3, 2, 1, 0, 1, 2. And matrix B is 0, 4, 1, 1. Remember, before we multiply anything, we check the columns and the rows. So the column of the first matrix here is 1, 2, 3. Now the rows of the second matrix is 1, 2. So rows is 2. That means multiplying matrix DB is not possible. Move on to the next. The next question, we ask multiply matrix AB. Matrix AB is simply a typical 2 by 2 matrix multiplication. So this is matrix A, which is 1, 2, 1, 3. And then this is 0, 4, 1, 1. Let me clean up space. So that means our matrix AB, if we want to multiply it, we have this one's multiplying this. So if we have this row for the first row first against the first column, remember, since we are dealing with the first row, everything we are multiplying goes into the first row of the new matrix. So we will be saying 1 times 0, 1 times 0 plus, this will be 2 times 1, 2 times 1. We are done with the first column of the second matrix, so we can go to the second column. That means that we'll be moving to the second column here. We'll say 1 times 4 plus, we'll say 2 times 1. We are done with the first row, so we can now move out of it. Then we go to the second row. Since we are now in the second row, everything we are imputing will be on the second row of the new matrix. So we use the second row and say this is 1 times 0 plus 3 times 1. We are done with the first column of the second matrix. So we can go to the second column. So this will be 1 times 4 plus 3 times 1. Then the matrix AB should be equal to 1 times 0 is 0 plus 2 times 1 is 2. 1 times 4 is 4 plus 2 times 1 is 2. 1 times 0 is 0 plus 3 times 1 is 3. 1 times 4 is 4 plus 3 times 1 is 3. So that this is equal to 0 plus 2 is 2. 4 plus 2 is 6. 0 plus 3 is 3. 4 plus 3 is 7. So the new matrix AB is a 2 by 2 matrix. To really check whether our order of matrix now is right, we can use what I did before. The original matrix for A was a 2 by 2 matrix. The original matrix for B was a 2 by 2 matrix. So supposedly we multiply the two matrices. We have a 2 by 2 matrix multiplying a 2 by 2 matrix. Remember, I said you remove the middle numbers so that the new matrix will be this one and this one. So we now have a 2 by 2 matrix. That means if we were to multiply these two matrices, the answer should be a 2 by 2 matrix. And from our answer, we had a 2 by 2 matrix. So that is it. That's how to solve multiplication of matrices. If you like this video, leave a thumbs up, share with your friends, and subscribe to the channel. Really helps. Thanks for watching.